For the 35th problem on the second ACT practice test, the parallel sides of the isosceles trapezoid shown below are 10 feet long and 16 feet long, respectively. What is the distance in feet between those two sides? So we need to figure out the distance in feet between this side here, which is 10 feet, and this side here, which is 16 feet. So in other words, we need to figure out what this distance is here. And to do that, we need to first recognize what an isosceles trapezoid is. So anytime you see isosceles, that just means that within your shape, two sides are going to be equal to each other. And you can see that we have 5 feet here and 5 feet here. But also within an isosceles trapezoid, the base angles are equal to each other, which implies that these upper angles here would be equal to each other as well. Now, the way to solve this, quickly at least, is essentially to use symmetry. So if you were to drop perpendicular lines here and here, you can essentially form two right triangles. So these are going to be right triangles, and all we have to do is figure out what this length here and this length here is. And since this is a symmetric figure, if we know that the total length here is 16 feet, and we know that this length up here is 10 feet, that means that between the two, there's a difference of 6 feet. So this length here, I'll call this x, and this would be the same length as well because of the symmetry. Then these two lengths, x and x, would have to make up that excess 6 feet. Or in other words, notice that by forming this rectangle here, we know that the length from here to here would be 10 feet as well, since the opposite side of that rectangle is 10 feet, which means that this length here and this length here both would have to add up to 6 feet. But we know that they're the same length. So if they both added together add up to 6 feet, and they're both the same length, that means they would each have to be half of 6. So in other words, each of these has a value of 3 feet. So let's take a closer look at one of these triangles, since they're both the same triangle, essentially. So after redrawing the triangle, we know two of the sides, and we know that it's a right triangle. So to find this missing side, which would be the distance between the 10-foot side and the 16-foot side, to find this, we would have to just use the Pythagorean theorem. And the Pythagorean theorem, in general, you can remember, is just a squared plus b squared equals c squared, where a and b, these are just the legs of the triangle, and c is the hypotenuse. So this 5 would be c, and you can call 3 either a or b. It doesn't matter. So we have that 3 squared plus, I'll call this side b squared is equal to 5 squared. 3 squared is just 9, plus b squared is equal to 5 squared is just 5 times 5, or 25. And now subtracting 9 from each side of this equation, we have that b squared is equal to 16. And taking a square root of each side, we find that b is equal to plus or minus 4. Since if you're taking a square root, you always have to consider the positive and the negative case. But we're dealing with a length here, which can't be negative, so b would just be 4. So the distance between these two parallel sides, this 10-foot side and this 16-foot side, is simply equal to 4. So this length here, this vertical line, is 4 feet. Now, a quicker way to do this is without using the Pythagorean theorem. Since the 3, 4, 5 right triangle is probably the most common right triangle. And taking the ACT, you're almost guaranteed to run into at least one triangle, one right triangle, that is a 3, 4, 5 right triangle. But you might also see a triangle composed of multiples of these numbers. So instead of seeing 3, 4, 5 for your right triangle, you might see 6, 8, 10, or you could see 9, 12, 15. So going into the test, it would be very helpful to memorize these 3, 4, 5 right triangles and their multiples, just so you don't have to use the Pythagorean theorem every time you have a missing side in one of these triangles. So answering this question, we know that the distance in feet between the two sides is 4 feet. So our final answer here would be this letter B.